have a glass of iced tea and a cup of hot coffee. If you don't drink it within a few minutes, the content and temperature of both drinks reach room temperature. This means that the two drinks are in equilibrium. If A and B are in thermal equilibrium with C, then they are in equilibrium with each other.
First law of thermodynamics. Conservation of energy. Energy can change forms, but is neither created nor destroyed. Real-life application. Photosynthesis, popping of popcorn. The energy is supplied by the sun. Light energy is absorbed by cells in plant leaves and converted to chemical energy. The chemical energy is stored in the form of glucose. The energy stored in glucose can also be released through cellular respiration. Familiar example is a quantity of popcorn kernels in a pot with a lid when the pot is placed on a stove. Energy is added to the popcorn by conduction of heat, as the popcorn pops and expands. It does work as it exerts an upward force on the lid and displaces it.
Entropy statement. When a reversible process occurs, the total entropy of the universe remains the same. When an irreversible process occurs, the total entropy of the universe increases. Here's some examples of second law of thermodynamics. Hot coffee becomes cold on its own because its temperature is higher than the surrounding temperature. Obviously, heat will flow from higher temperature to lower temperature. In this way, heat of the coffee is rejected to the surrounding. The entropy of the universe increases by its process. Heat always flows from higher temperature body to a lower temperature body. The surrounding is a higher temperature body and ice is a lower temperature body. So heat will flow from the surrounding to ice. This ice will absorb heat from the surrounding and it will melt. This process occurs on its own and the entropy of the universe increases. Air leaks from the balloon. Air always comes out of the balloon on its own. It never goes inside the balloon on its own. This phenomenon is based on the entropy statement of second law of thermodynamics. What is third law of thermodynamics? German chemist Walther Hermann Nernst studied about the second law of thermodynamics. His mind was completely disturbed. He studied that the entropy of the universe keeps on increasing for all the process occurring on its own. Then he studied everything about entropy. After a lot of studying and research work, he discovered the third law of thermodynamics. The third law of thermodynamics states that the entropy of a pure crystal at absolute zero is zero. Absolute zero. The temperature at which all particle motion almost stops. The temperature is known as absolute zero, and it's the lowest possible temperature. It is equal to minus 273.15 degrees Celsius for 159.67 degrees Fahrenheit and 0 Kelvin. Third law of thermodynamics explains entropy. Entropy is the measure of the disorder in a system, and while a perfect crystal is by definition perfectly ordered so that the entropy of that crystal is zero. Whenever asked to explain the third law of thermodynamics, it is necessary to mention the pure crystal state of the matter. This law helps us understand the ability of atoms to be random. This law helps us understand that motion, heat, and order are related. The more molecules can move around, the more heat they create, and the more entropy or disorder. The more you study heat and energy and work, the more these laws help us understand what is happening in the universe. Third law of thermodynamics. Real-life examples. The first example is a messy room. Remember that entropy is a measure of disorder in a system, therefore, the entropy of the room is high because things scattered everywhere. And if the owner is going to tidy it up, the entropy will decrease because the things are organized. The second example is a successful relationship. Successful relationships require care and attention. We use this as an example because successful relationships are very crucial in our daily life. People who have healthy relationships are more likely to feel happier and satisfied with their lives. How is it connected with the third law of thermodynamics? Here's the crucial thing about entropy. It always increases over time. It is the natural tendency of things to lose order. This insight that disorder has a natural tendency to increase over time, and that we can counteract that tendency by expending energy reveals the core purpose of life. We must exert effort to create useful types of order that are resilient enough to withstand the unrelenting pull of entropy. We need to fix everything that loses order. Just like having a successful relationship, it is normal to argue and have a misunderstanding sometimes, and it cannot be fixed if we do nothing. We need to do something or efforts to fix and keep the good relationship we have with someone. Lastly, this law shows us that nothing in the universe is perfect. We all need grace, because we all have the tendency to be broken, disordered, and wearing down. We are all imperfect human beings, but the God of the universe offers his perfect love to all of us, doing his mighty work of healing and bringing us into complete wholeness. That's pretty much the best news in the whole universe.